The DreamBot project has been granted to us by the European Commission, specifically by the Manufacturing Industries Digital Innovation Hubs, or the MIDIH project. This was part of an open call that we had applied for last year, and we received a grant that allowed us to develop some very novel technology to grow and accelerate our startup.
Let's start with the European Commission's Digital Innovation Hub strategy because it's an important part of the story. One of the main goals of the European Commission is to ensure that all EU companies, large or small, find ways to adopt the latest digital technologies in their products, processes, and services. To support this, they implemented a new strategy called Digital Innovation Hubs, or DIHs. DIHs are essentially expert centers led by leading EU research organizations that offer expertise and business-oriented services, including funding, to help companies become more competitive through the use of technologies such as robotics, artificial intelligence, and the Internet of Things. The Manufacturing Industries Digital Innovation Hub, or MIDIH, is a European Commission project specifically aimed at supporting manufacturing SMEs, which includes both technology users and providers, such as startups. One of the main goals of the project is to provide funding to companies so that they can develop industry-ready solutions and experiment with them in real-world applications. The only requirement is that the experiments should relate to one or more components in an industrial IoT reference architecture that has been developed by the MIDIH project. Tractonomy was awarded a grant by the MIDIH project to develop a novel machine learning-enabled navigation solution that runs in the edge and in the cloud to improve the autonomous capabilities of our mobile robots.
So Tractonomy is a robotic startup that builds autonomous mobile robots like the ones you see here for handling industrial carts. Our goals are to make these robots drive around, pick up carts from one location and move them to another location, but as flexibly as possible.
Tractonomy's value proposition goes beyond just selling robots for cart handling. We know that our customers will operate our robots in facilities that are not easily accessible. And our robots cannot stop functioning because it costs our customers a lot of time and money. So we offer a maintenance as a service cloud platform, which allows our customers to focus on their operations while we handle the maintenance of their robot fleets. Using analytics and remote maintenance specialists, we can let our customers know in advance if an AMR is going to have a problem so that we can prevent these downtimes for our customers and keep their operations going. The aim of the DreamBot experiment was to develop a navigation solution that uses artificial intelligence techniques to recognize and guide our robot towards a group of parked carts. While AI techniques such as artificial neural networks are becoming increasingly popular, they still require a lot of resources to run on the limited computing power that's typically available on robots, including our own. So one option is to stream the robot's sensor data over wireless to a server which is running locally in the factory or warehouse or in the cloud, where the computing power is abundant or even limitless. One of the challenges of real-time streaming to the cloud is that wireless networks in industrial environments are not always very reliable. Moreover, streaming 2D and 3D images over the network can quickly overload the wireless network. So in the DreamBot project, we ran a series of experiments by testing our robot communicating with the cloud. And we varied the delays and the losses in the network to find the limits of our solution in real-world conditions.
So our architecture, which we developed during the MIDIH project, is part of recognizing and perceiving objects in a manufacturing scene. So in this case, we try to recognize carts. So at the start, the robot starts to figure out where the carts are. And defined by the user is a pickup location where the robot needs to go to start looking for carts. The initial phase is where it approaches a cart, but it's not really visible yet. So then it starts to recognize carts which are in the area of the pickup zone, and that's where it actually can use artificial intelligence to detect those carts.
And as he's approaching that location, what the robot's going to do is he's going to open up his sensors and he's going to start looking in his environment for carts. And that's when the artificial intelligence kicks in, start to recognize where the carts are located with respect to the robot. Once the robot has identified where the carts are, he can then start planning his motion to those particular locations to pick up the cart. This project has been immensely helpful to us. We've been developing this robot since early 2019, and robotics is not easy. It takes a lot of effort. We've been putting a lot of hard work into it. Funding is extremely important for young startups in Europe, and with the money we can do a lot. We were able to hire Elias on the project, and he's got a lot of good background in artificial intelligence and robotics. That's exactly what we wanted because it complements our team perfectly. And with him and us working together, we've really accelerated the development of our product through the support of the European Commission and the MIDIH project. And now we have a technology platform which we can grow on. We can expand it out into different applications, especially applications that our customers will really trust and use. That's very important for us as a startup. So yeah, we can't thank the European Commission and the MIDIH project enough for the support.